Here's problem number 29. What is the kinetic energy of an alpha particle that is not deflected in a velocity selector in which the magnetic field is equal to 20 millitesla and the electric field is 4 kilovolts per meter? Well, if we have an alpha particle, the mass of an alpha particle is 4 times the atomic mass unit. And the atomic mass unit is approximately the mass of a proton, 1.67 times 10 to the minus 27 kilograms. So this is going to be 6.68 times 10 to the minus 27 kilograms for the mass of the alpha particle. Now if we have a velocity selector, this alpha particle, which is comprised of 2 protons and 2 neutrons, traveling with some velocity v, if it is undeflected in a velocity selector, that means that the magnetic force, QVB, is being offset by the electric force. So they must be equal in magnitude, opposite in direction. So QVB equals QE. The charge cancels out. And that means that the velocity is equal to the E field divided by the B field. In this case, that would be 4,000 volts per meter over 20 millitesla. So that's going to be 4 divided by 20, which is 0.2 times 10 to the 6, which would be 2 times 10 to the 5 meters per second. So that is the velocity of our alpha particle. Hence, the kinetic energy is 1/2 the mass times the velocity squared. And that's going to be 1/2 the mass, 6.68 times 10 to the minus 27 for our alpha particle, times the velocity, which is non-relativistic. So this is certainly the right way to calculate the kinetic energy. 2 times 10 to the 5 and that quantity squared. So this is equal to 1.336 times 10 to the minus 16 joules. If we want to convert that to electron volts, we note that there is 1 electron volt per 1.6 times 10 to the minus 19 joules, and that will give us 835 electron volts in kinetic energy. So the energy of this alpha particle is 835 electron volts.